New perspective on the cosmos. Then in 1997 the Hubble Space Telescope discovered something extraordinary. The universe's expansion wasn't slowing down, it was accelerating, driven by a mysterious force we now call dark energy. This discovery led to the current estimate of the universe's age, 13.8 billion years. But new evidence from the James Webb Space Telescope is shaking the foundations of this timeline and rewriting the rules of the cosmos. Deep within the Milky Way galaxy, a star cluster known as M92 has left scientists scratching their heads. Why? Because this dense cluster of ancient stars is believed to be as old as the universe itself, 13.8 billion years. And some estimates even suggest it could be even older. How can this be? The very idea, how can this be, defies logic. Stars cannot predate the universe, yet the data from M92 challenges our deepest assumptions about the cosmos. Using cutting-edge techniques, astronomers simulated over 20,000 synthetic star populations to calculate the cluster's age. The result, an age so close to the universe's supposed beginning that it raises an uncomfortable question. Have we been wrong about the universe's timeline all along? Enter the James Webb Space Telescope, the most advanced eye humanity has ever turned toward the heavens. Webb has peered deeper into the cosmos than ever before, uncovering galaxies that existed just 300 million years after the Big Bang. But here's the kicker. These galaxies are far more massive and mature than they should be for their age. Could the universe be older than we think? The discovery of these impossible galaxies combined with the paradox of M92 suggests we may need to rethink everything we thought we knew about the age and evolution of the universe. This brings us to a radical new hypothesis. What if the universe isn't 13.8 billion years old? A recent study proposes a staggering alternative, 26.7 billion years. This theory suggests that our current understanding of the universe's expansion and formation of early stars and galaxies might be incomplete, or even fundamentally flawed. From the mysterious Methuselah stars that seem to defy age to the mature galaxies spotted by Webb, the evidence points to one conclusion. We may be on the verge of a new scientific revolution. But this isn't just about numbers. If the universe's timeline is wrong, what does that mean for our understanding of life itself? What mysteries lie in the billions of years we have overlooked? Nestled within our cosmic backyard lies one of the universe's most perplexing puzzles, the Methuselah star. This ancient star, formerly known as HD 140283, is estimated to be 14.5 billion years old, nearly a billion years older than the universe itself according to current models. How is this possible? Stars follow predictable life cycles, burning through their fuel at rates dictated by their size and composition, yet Methuselah defies this logic, seemingly aging slower than the universe around it. The Methuselah star isn't just an anomaly, it's a beacon pointing to deeper questions about the origins of our cosmos and the limits of human understanding. At the heart of the age debate lies a single stubborn number, the Hubble constant. This value describes the rate at which the universe is expanding, and it is a cornerstone of cosmology, but there's a problem. The Hubble constant refuses to agree with itself. On one side, measurements of the early universe using data from the cosmic microwave background suggest an expansion rate of 68 km per second per megaparsec. On the other, measurements from nearby stars and galaxies push that number closer to 73. This discrepancy, known as Hubble tension, has left scientists scratching their heads. If we cannot agree on the universe's expansion rate, how can we accurately measure its age? What if the answer lies beyond our current understanding of physics? What if dark energy, or even new undiscovered forces, are at play? One of the James Webb Telescope's most groundbreaking achievements has been its ability to peer into the dark ages of the universe, the period before the first stars were born. What it's found there is nothing short of astonishing. Just 300 million years after the Big Bang, Webb has identified galaxies with masses and structures comparable to that of the Milky Way galaxy. And these galaxies shouldn't exist, not yet, according to the current timeline. They would need billions of years to form. But as Webb continues to uncover galaxies that defy explanation, it raises a provocative question. Is the Big Bang model itself incomplete? Amid the growing evidence that the universe's age may be far older than the accepted 13.8 billion years, some scientists are turning to an even more radical idea, the multiverse. What if our universe is just one of many, each with its own timeline and physical laws? In such a scenario, the discrepancies we see, like the Methuselah star or the ancient galaxies, might make perfect sense. The multiverse theory suggests that our universe's apparent contradictions might be the result of interactions with other dimensions. Could it be that the James Webb Telescope is offering us a glimpse of these neighboring realms? If true, the implications of this theory would extend far beyond astronomy, challenging the very foundations of how we perceive reality itself. As the James Webb Telescope forces us to reconsider the universe's timeline, a forgotten theory has threatened to resurface: the idea of a cyclic universe. This theory suggests that the universe hasn't just existed for 13.8 billion years. It has gone through countless cycles of expansion and contraction, big bangs followed by big crunches. Could the ancient stars and galaxies spotted by James Webb be echoes of a previous cosmic cycle? And if so, what clues might they hold about the universe that came before ours? Another puzzle uncovered by the James Webb Telescope revolves around the mysterious existence of primordial black holes, these dense objects thought to have formed just moments after the Big Bang. They may hold the key to understanding the age and evolution of the universe. Primordial black holes could explain the existence of the impossible galaxies Webb has observed, acting as gravitational anchors that sped up galaxy formation. But their presence also raises a troubling question: what else about the universe's early history are we missing? We know dark energy as the mysterious force driving the universe's accelerated expansion. But could it also hold secrets about the universe's true age? Recent observations suggest that dark energy might not be as constant as we once believed. Instead, it could be evolving, altering the universe's expansion rate over time in ways that challenge our understanding of the cosmos. Now, if dark energy has changed over time, it could explain the rapid formation of galaxies and the apparent contradictions in the universe's timeline, but it also opens up a Pandora's box of new questions. At the smallest scales of the universe, where quantum physics governs reality, time itself begins to break down. Could this be the key to the mysteries uncovered by the James Webb Telescope? Quantum theory suggests that the early universe may have experienced phenomena we can barely comprehend, fluctuations that could create entire galaxies or even alter the flow of time itself. From time dilation near black holes to the quantum mechanics of the Big Bang, the James Webb Telescope's discoveries are forcing us to confront the most profound questions about reality. Underscore 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 underscore. Conclusion. The James Webb Space Telescope has not only deepened our view of the universe but has also cast doubt on the very foundations of modern cosmology. From ancient stars that seem older than the universe to impossibly massive galaxies formed in its infancy, the evidence is mounting. The story we've been telling about the cosmos may need to be rewritten, but rewriting that story isn't just about understanding the universe's age or its history. It's about something much larger. Each new discovery made by Webb reminds us of the boundless mysteries waiting to be uncovered and the incredible potential of human curiosity. What if the universe isn't 13.8 billion years old? What if it's 26.7 billion? Or even timeless? What if our universe is just one chapter in a grander multiversal epic? One thing is certain: the James Webb Telescope is more than a machine. It's a time traveler, a storyteller, and a key to the secrets of existence. With every image it sends back, it challenges us to dream bigger, to question everything, and to embrace the unknown. So what do you think? Are we standing on the edge of a cosmic revolution? Let us know in the comments. And don't forget to like, share, and subscribe for more journeys into the mysteries of the cosmos. As the astronomical community grapples with these implications, the broader public is beginning to grasp the monumental consequences of what the James Webb Space Telescope might have uncovered. No longer are these abstract measurements and numbers confined to elite scientific circles. They are slowly redefining the very way we understand our place in the cosmos. If stars like Methuselah are older than our models allow, and if entire galaxies formed far too early, then perhaps the Big Bang wasn't a singular moment but part of a much deeper and more complex cosmic narrative. This shift in thinking invites us to reflect on the philosophical questions as well. If the universe is significantly older, what does that mean for the origin of life? Did life have more time to arise elsewhere? Could civilizations far more advanced than ours have had billions of additional years to evolve, flourish, or even perish before our sun was born? If the multiverse is real, and other universes coexist beyond our own, could intelligent life be thriving under entirely different physical laws? The mere suggestion opens the floodgates of imagination, stretching not just science but philosophy, theology, and metaphysics. Some physicists now advocate for reinterpreting cosmological constants that we once thought unchangeable. The speed of light, gravitational forces, or even the behavior of time may not be consistent across all cosmic epochs or dimensions. These speculations might sound outlandish, but they're gaining traction precisely because Webb is revealing inconsistencies our current models can't reconcile. Every time the telescope peers farther, it finds more anomalies, structures too large to have formed so early, black holes that should not exist, and cosmic patterns that suggest some yet undiscovered organizing principle. Moreover, the question of time itself becomes elusive. Einstein showed that time is relative, that it stretches and contracts based on gravity and speed. But at the quantum level, time might not flow in any linear sense at all. Some theories propose that time is emergent, not fundamental, a byproduct of entangled particles interacting in complex ways. If that's the case, our linear timeline of the universe, starting from a Big Bang 13.8 billion years ago, might be an illusion, a construct that only makes sense from our vantage point. In light of this, the cyclic model of the universe has gained renewed interest. Ancient traditions and modern physics alike have toyed with the notion of repeating cycles: birth, growth, death, and rebirth on a cosmic scale. Some string theorists even argue that the universe oscillates through brane collisions, giant dimensional membranes crashing into one another to create new universes. In these scenarios, our universe might be one phase in an eternal process, and the Big Bang just the latest act in a drama without beginning or end. The implications of such models go beyond astronomy. They touch on the idea of permanence and impermanence, on the nature of creation and entropy. Could there be imprints of previous universes embedded in the cosmic microwave background? Are there fossils of previous cycles etched into the quantum foam of space-time? Future instruments, even more sensitive than Webb, might be able to test these questions. Meanwhile, dark energy and dark matter, two of the universe's greatest enigmas, continue to defy our understanding.